Spectrum analyzers are most frequently used to measure and observe signals in the frequency domain, but another useful feature can be to configure the analyzer for time domain measurements. Let's take a look at measuring some specifications of AM signals using a spectrum analyzer configured for time domain measurements. Let's set the middle frequency of the spectrum analyzer as the carrier frequency of the modulated wave and open zero span mode. The analyzer now works as a regular tuned receiver where the resolution bandwidth, or RBW, sets the bandwidth of the receiver. The curve displayed shows the relationship of input signal, amplitude, and time. Adjust the span time to make the spectrum display multiple periods of the modulated signal. Note that the analyzer's resolution bandwidth should be greater than or equal to the DUT's bandwidth. That is the frequency range between the two sidebands, and it should be 20 kHz to avoid missing the signal information. At the same time, the video bandwidth, or VBW, should be equal to or greater than the resolution bandwidth to avoid trace smoothing. If the analyzer is set to free trigger and the signal can't be displayed stably, choose video trigger and adjust trigger levels to lock in on the signal. The green line in the picture shows the current trigger level location. Note that the trace has been triggered stably. Then we can adjust the scale per division to make the signal display on the screen in a suitable location. We can perform modulation measurements using marker functions. Open a normal marker and locate it to a peak. Change the marker to delta. Adjust delta marker to another near peak. Then set marker readout to 1 over time. Now the reading of the marker is the modulated frequency of 10 kHz. When testing mod depth, we can open two normal markers and locate them at the max peak and min peak. Then set Y unit as volts and open the marker table to display the amplitude value of the two markers. Calculate the mod depth according to the given formula, M equals Pmax minus Pmin divided by Pmax plus Pmin. If we change the scale per division type as linear, you can see there will be a more perfect modulated waveform. This concludes our introduction to using the zero span function of a spectrum analyzer to perform time domain measurements. Here are some notes. Set the frequency according to the input signal. Enter zero span mode. Adjust the span time and video trigger level, and then use marker functions to perform the measurement. Thank you.